Okay, for this video I'm going to run through an example, and I downloaded some data from the internet, which is some pretty trivial data, but it might be useful and interesting to most of you guys. So we have college GPA and high school GPA. That's what these cryptic variable names are. And then SAT total and quality of letters of number of quality letters of recommendation. So, and I'm just going to switch over to my regression code, and you can see that I read the data in. It's a CSV file, and it has a header with the variable names in it. And then I can do a structure, which I did already, but I just want to save that so you can see. And you can see here it's a data frame with 100 observations and 4 variables. And here's the college GPA, high school GPA, SAT total, and the number of quality letters of recommendation. And then what I did was I did a quick plot of it. And this is a scatter plot, which I find useful because you can take all 4 variables and do a quick scatter plot. And you can take a look to see whether there are any reasonable effects or correlations here. And I don't know whether this is real data. I just downloaded it off the internet, but you can see here college GPA is the dependent variable and high school GPA as the predictor. That looks pretty good. So maybe what we'll do is we'll use that. So I'm going to use high school GPA as a predictor of college GPA. So I think we're up to LM3, and college GPA as a predicted by GPA high school GPA. And this is the way I do it. So I'm going to do a summary of, and this is what I get. I have an intercept, and remember that all of this, these are B's, so these are unstandardized regression coefficients. So my intercept is 0.822, and my B is 0.56, and because these are B's, these are expressed in terms of college GPA units divided by high school GPA units, and this B is an unstandardized regression coefficient. It doesn't, we can't readily interpret it unless we knew what the metric was of each one. And I showed you in a previous video that in order to have something that would be readily interpretable, what we do is scale college GPA and then tilde, scale high school GPA, and then subtract out that data equals that. Notice that I have to put the data referent in now because now I have a data set. LM3Z. Before I just had variables that I created, so it was a little bit easier. But now what you have is I have unstandardized regression coefficient, or excuse me, a standardized regression coefficient, 0.54520. Yeah, it differs a little bit, but not a whole lot. And that's the same as the correlation. If I just did the correlation of, let's see, I can just do correlation for that. It gives me a correlation matrix, and if you look at here, this, college GPA and high school GPA, it's 0.4520. It's rounded, and that's what we have here. So as an example, what we've run through is the calculation of A and B. So here's the intercept, and here's the slope. And what I do want to do is give you the plot of college GPA tilde high school GPA, and then I want to superimpose a regression line, and I'm going to colorize it and make it a little fatter because I like it that way. Okay, whoops. Forgot that, and that's going to be a problem. And there you go. Not sure why it didn't give me a red, but I can figure that out later. Oh, because it's not color, it's col. Okay, much better. So there we go. And what we have here is a line of best fit that goes through these unstandardized values for x and y. And this is the way we would look at it normally, and then we'd try to figure out whether this line of best fit accurately portrayed the data, the observed data, and we can then run regression diagnostics, which we're going to talk about in great detail later. But I just want to show you just how simple this is to run some of these analyses, and now that you know how to interpret and also how to compute A and B, we're not going to do any laborious exercises in class, but I do want you to be able to read in the data and run a bivariate model and be able to identify and understand why A and B differ from beta and how to calculate it and what the standard error of B and what the standard error of A represent, and then how to conduct them and how to interpret the results. So that's what we're working on from now on. Is I think you have a pretty good understanding of bivariate regression, and we're going to move a little bit quickly through including extra predictors and then interpreting B and beta from that as well. So stay tuned. I have one more video that gives some extra applications of multiple regression and correlation.